Good afternoon, everyone. Today we continue to solve problems from British Physics Olympiad 2017. Today we have problems E and F. So let's start from E. We have a helicopter. Let's draw something like helicopter and propeller with mass 1000 kilograms. That remained in stationary position. So it means that its balance of force, so net force, is 0 according to Newton 1. So we have weight force that acts downward, and it should be some opposite force, but equal in magnitude, that acts upward. Let's call it F. So what can be this force? We see that helicopter moves air, so we can consider force like a change of momentum of air that goes downward. And we have to find a speed of this air. So force, we can call force a change of momentum with time, and it's equal to delta mv over delta t. We don't have acceleration here, so it's better to play with mass. So we put speed here, and we have change of mass with change of time. Remember, it's mass of air, it's not mass of helicopter. So now let's look at, we have also a density of our air as well as a diameter of this column, because it's like a cylinder of air that goes downward. So m is equal to v multiply density, and we can say that volume, because it's cylinder, its area of the circle S multiply length L multiply density. So it's our m. Let's substitute it back here. So we have F is equal to V delta M delta T, that is equal to V, because we know density doesn't change, area of circle doesn't change, only thing that change is length, especially because like every second propeller moves some cylinder of air downward, and that gives us impulse. So it's a change of length. A change of length with time, it's speed. So it's equal to rho s delta L over delta T equal to V square rho s. And now, so we can write, we can find V. V is equal to square root of F over rho s, and s, it's an area of circle. We have diameter. We can solve it through diameter is equal to pi d square over 4. So we put 4 here, and F is equal to weight. This is equal to mass multiply gravitational field constant. So it's equal to root of 4 mg over rho pi d square. So now it's a formula, and when you use calculator, you can find out that it's 17 meters per second. So we solve this task. So let's go to next problem. Next problem, it's problem F. It's a vector problem, so we have to draw axis first. We have axis, vertical axis and horizontal, and we have here two unit vectors, I and j. So let's draw I here and j here. So what can we draw here? First of all, we can draw position vector of motorboat at 2 p.m. and because it's minus 4i minus 5j, it's approximately here in this quadrant. So it's our position vector of motorboat. We also have magnitude of velocity vector, but we don't know what is velocity vector, so we just remember it but don't draw. We also have ship. Ship has a position at 3 p.m. 3i minus j, so it's approximately here, its position. And we also have velocity vector I plus 4j. We would draw it here because like for this one, it's velocity vector of ship, but we can also move it like parallelly on parallel line. So velocity vector of ship is here from this position. So what now? First of all, find a position vector of the ship at 2 p.m. It's the easiest one because we have velocity, we have a position at 3 p.m. So it's equal to position vector, in our case is 3i minus j, minus t time difference, it's 1 hour in our case, multiply velocity vector I plus 4j. And t is equal 1, so we just subtract this from this, and we get 2I minus 5j. So we solved first one. Second one, velocity vector of motorboat. It's harder, but still, first of all, we assume that velocity vector has a form ai plus bj, because the expressions show unit vectors. So velocity vector of ship, of motorboat, is ai plus bj. So how can we solve it? We know that two ships will intercept in some moment of time, and let's call time between 2 p.m. and this time of intersection t. So we can find out that in some moment in the future they both will have the same position. So we have initial position at 2 p.m. of motorboat is its position vector minus 4I minus 5j plus t over ai plus bj, and it's equal to initial position 2 p.m. of ship, we counted it, it's 2I minus 5j, 2I minus 5j, plus t over its velocity, and velocity of the ship is I plus 4j. So let's move all expressions with t in right part and without t in left part. So let's subtract. Minus 4I minus 2I is equal to minus 6I minus 5j plus 5j is equal to 0j. Always leave 0 because it will be needed later. It's equal to t I minus ai plus t for j minus bj. So now we can factorize it more and get minus 6i plus 0j is equal to ti 1 minus a plus t j 4 minus b. So now we can make system of expressions because we know that I can only add or subtract and make I number, and with j is the same, so we have that 0 is equal to 4 minus b, like t4 minus b, and minus 6 is equal to t1 minus a. It's obviously that in this case t isn't equal 0 because in the 2 p.m. both ships are in different positions. So we have that 4 minus b is equal to 0, so b is equal to 4. So we found b. Now we can use our magnitude, because magnitude is a square plus b square is equal to root 41 square. So a square plus b square is equal to 41, and we know b, so we can find a. It's a root of 41 minus 16. It's root 25 is equal to plus minus 5. But we know that ships moves in this direction, motorboat moves in this direction, so I should be a it's like ai, it should be positive, so it's 5. So our velocity vector of motorboat is equal to 5I plus 4j. So what now? We have time. Now it's easier because we have other expression. Let's use expression for I. Minus 6 is equal to t1 minus 5. So t is equal to minus 6 over minus 4. It's equal to 3/2, and it's equal to 1.5. So this means the ship will meet in 3:30. So that's it.